Find the set of values of x for which 3 lots of x minus 2 is less than 8 minus 2x. So let's expand these brackets. The 3 lots of x is 3x. The 3 lots of the minus 2 is minus 6. Now let's collect up the like terms. So I'm going to move this minus 2x to the left hand side, so it's grouped up with the 3x. So I'm going to add 2x to both sides. I'm then going to add 6 to both sides. So I will get 5x has to be less than 8 plus 6, which is 14. So therefore x has got to be less than 14 over 5, or less than 2 4/5. Part B, we need to find a set of values of x for which 2x minus 7 multiplied by 1 plus x is less than x. So this is already given to us in factored form, which is useful. That's good. So I can straight away draw my sketch to solve this quadratic inequality. So here's my sketch. Now, because it's in factored form, this is telling me that one of the roots is at 7 over 2, or 3.5. So let's mark that on roughly here. And then this is telling me that the other root is at minus 1. So my quadratic looks something like this. I want the sets of values where it is less than 0, so negative, or below the x-axis. It's below the x-axis in this region here, where the x-coordinates are between minus 1 and 3.5, or 7 over 2 if you prefer. So those are the set of values for where that quadratic is less than 0. Part C, find the set of values of x for which both 3 lots of x minus 2 is less than 8 minus 2x, and the 2x minus 7 times 1 plus x is less than 0. So the set of values of x for where this is true and this is true. Well, the first equation is saying that x has to be less than 2 4/5. The second equation is saying that x has got to be between minus 1 and 3.5. So combining those together, I can see that x has to be bigger than minus 1. That's the smallest that it could possibly be. The second inequality wouldn't be true if x was less than minus 1. And the biggest that x can be is 2 4/5. That is the biggest that x can be, so the first inequality is true. And as long as x is less than 2 4/5, then the second inequality will be true as well. Alternatively, a different way you can think about part C, if I was to just draw a number line, and we'll go from minus 2, minus 1. The first inequality is true as long as x is less than 2 4/5. So 2 4/5 is roughly about there. So as long as x is any of these values, less than 2 4/5, the first inequality is true. And the second inequality is true as long as x is between minus 1 and 3.5. So where are both of them true? In this region here where x is between minus 1 and 2 4/5. So that's your answer for C.